In Chapter 2, we're going to begin looking here at descriptive statistics, graphs in particular, and we're going to start with something called a stem and leaf graph or a stem and leaf plot. This is a way of organizing the data where you break off the last significant digit, we call that the leaf, and then all the preceding digits we call the stem. And it helps us see the distribution of the data. It also works well for small data sets. Let's look at an example here. So here we've got number of points scored during each of 16 games by a high school basketball team in the last season. So they scored 56 points in the first game, 54 points in the second game, and so on. We're going to construct a stem and leaf display or graph of the data and then interpret the plot. So we're going to start out here by splitting off the ones digits from the tens digits for points. So I notice here that it looks like the high is about 71 and the low is 36. So we're going to have scores go from the 70s down to the 30s. So I'm putting the tens digits to the left of this vertical line. So everything that's 70 some points goes here, 60s points, points in the 50s, 40s, and 30s. So I see that 71, so I'm going to take the ones digit, the leaf, and put a 1 there. I'll go ahead and mark that off. And then let's go ahead and do everything in the 60s. So I see I've got a 61, another 61. So I've got two ones in the 60s row. So this is 61, 61, breaking up the ones digit from the tens. I got a 68 and a 60. So I'm going to put the 8 here and the 0 here, again breaking off that ones digit. Then we've got a 66 and a 61. So a 6 and a 1. And then 64 is our last one. So we need a 4 in the 60s row. Now let's do all our 50s. So we've got 56 and 54. So we're going to 6 and a 4 in the 50s row. We've got a 55 and a 54. I have a 5 and a 4, and notice how I'm lining up these ones digits. And then we've got a 52 and a 51, so a 2 and a 1. Now 40s, so we got a 46 here. And it looks like the only thing left is that 36. So there's our stem and leaf plot. Now one thing we want to do is we want to rearrange these digits here so that they increase as you go from left to right. So we'll redraw our stem and leaf here. 70s, 60s, 50s, 40s, and 30s. No rearranging with the 71, but here we've got 60 and then 3 61s. So 0, 1, 1, 1. And then we had a 64, 66, 68. So 4, 6, 8. So I just arranged those ones digits in increasing order. Do the same with the ones digits in the 50s. So we've got 1, 2, 4, 4, 5, 6 in increasing order. And no rearranging to do down here. So there's our data. And we can go in increasing order up from the bottom, left to right. We know what everything is in increasing order. That makes it very easy to find the median, among other things. So let's go ahead and interpret our plot. So the C here stands for center. The O for outliers, the S for symmetry, and the second S for spread. So this is our acronym, COSS. So you want to tell me what's the sauce. So what's the center of this distribution? Well, we can count up here, let's see, 2, 4, 6, 8, 10, 12, 14, 15, 16 items. So 8 below the median and 8 above the median. So 1, 2, 3, 4, 5, 6, 7, 8. So that means our center would be right in here, actually between the 56 here and the 60. So our center, in this case, the median is about 58. Outliers here, I don't see any gaps in the data. That 36 could be a possible outlier because there is 10 units in between the 46 and the 56. So that could be a possibility. But if you see a gap here, so like if we had no numbers in the 20s, but then we had a number in the 10s, like 14, and you see a gap right there, then that means that since there's quite a big gap, this is a possible outlier. Okay, well, we don't see any gaps in our data. So I would look at this and I'd say, well, you know, possibly 36. There's no gaps, but there is a difference of 10 between those two bottom values. Symmetry. So think of this as a frequency distribution. It's kind of tipped on its side here. And I'm going to draw the curve that would go across the top of this. And you can see that it is fairly symmetric here. If this, this 6 was missing, it would be almost, dead symmetry here. So for symmetry, this is a symmetric, fairly symmetric distribution. And our spread, this data is almost all concentrated in the 50s and 60s. So concentrated in the 50s and 60s. So this data is not very spread out. Now, if we only had 1 or 2 values, but they were spread out over more stems here, then we could have less concentrated data. So center, outlier, symmetry, spread. Now, a common question I get from students is, do I have to start with the highest number and go down, or could I start with the 36 up here and have the numbers increase as I go down? Either way, okay, there's no set standard on which way to do that.